So I have up here on the board an equation that you learned last year, and pretty obvious that it is the equation for a parabola, since I have the great big old word parabola written up there beside it. And you know that anything that has an x squared in it, a y equals an x squared, is going to be a parabola. One form of the equation that you learned to work with last year looks like this. And I'm hoping we can kind of work together to remember what those different letters in this equation tell us. Besides the x and the y, I have a whole bunch of letters in there. And do you remember what any of those tell you? Okay. Okay, so one of the things about A is kind of how much it stretches, so kind of how steep, how wide or skinny it is. Okay, what else? There's also another thing that A will tell us, and I'm also wondering about the H and the K. Does anybody remember anything about those? What else are you remembering, Elizabeth? So, like any function, if we have a K on the outside, plus K it goes up, minus K it goes down. So K is going to tell us about the vertical shift. Let's see, Morgan. H is going to tell us about the horizontal shift, like on any function. If we have on the inside x plus or minus something, if we have x minus, it shifts right. If we have x plus, it shifts left. What's a special point on the parabola y equals x squared? If I just had the most basic parabola y equals x squared, what would be a particular critical point that you'd know exactly its coordinates on? Grace? 0, 0. So let's take that 0, 0 from our basic parabola. If we shifted it, let's suppose this is a minus some positive h and a plus some positive k. So if I shifted 0, 0, h to the right and k up, where would my vertex be? H, comma, K, and I just gave away a word on there that it's the vertex. So when we had it like this, the vertex was H, comma, K. So this is going to be vertex form of our equation of a parabola. If we have it in this form, we can look at it and take the opposite of what we have here on the inside of the parentheses, the same as what we have on the outside, and that tells us our vertex for the parabola. Do you remember doing some of those last year? We had you graph parabolas, and in the left side of the box we said write down what is the vertex, and we asked you a whole bunch of other things about it. That was one of them. So what else does A tell us about the parabola? How do you know which way it's going? What do you look at to tell on that? Anybody remembering? How do I tell if I'm getting a parabola that's doing like this or like this? What do we have on that, Sophie? So positive, it's going to open up. Negative, it's going to open down. And as Kay pointed out, it also tells us something about how fat or skinny it actually is. So let's start to get some of this down. Let's get this one in our formula list. The vertex form, because we can look at it and say the vertex is HK, is like this. And if A is positive, it opens up, and if A is negative, it opens down. And HK will be the vertex. The middle one on there I haven't mentioned yet today, but we did this a lot last year. If we had a parabola and its vertex was HK, doesn't it always have an axis of symmetry that goes right through that vertex? Vertical lines are always x equals a number. horizontal or y equals, but this is a vertical line, so x equals a number, and the number x would have to equal. If it goes through HK, the x has to be h. So x equals h was the axis of symmetry, and last year we also, one of those other things was, what is the axis on there? And so you needed to write down x equals some number, not just the number, because it needs to be an equation. X equals to say it's a vertical line. Not just 3, but x equals 3. Or x equals -7, not just -7. So as we're graphing these, we've mentioned a couple of the things that we had to do last year. We had to get it in vertex form if it wasn't already there, and we're going to be reviewing today how we do that. So we had to get the equation in vertex form. You had to write down the vertex, whether it was opening up or down, what the axis of symmetry was. What were some of those other things we asked you? Anybody remember other things on a parabola that you needed to be able to figure out what they were or label them on the graph? What other kinds of points did we care about? It's kind of like points we care about on a lot of things. Olivia, you remembering some other things? Give it a shot. It's a guess. We're trying to work together. What do we remember? Max and min, those were that was the vertex, and you're doing a great job remembering some of the application problems. We asked you when we started doing these with calculators and saying whether it was a max or a min. When we were just drawing the graph, we had to label what those coordinates were for the vertex. And what were other special points that we had to label? So if I've got some sort of parabola, I don't know, maybe it looks like that. What might, and I've labeled this point. What might be other points I try to figure out what the coordinates are? Chloe? The x and y intercepts. And we're going to be doing all of that same kind of stuff. So in general, the things that I'm going to be looking for will be these, and I'm not going to be quite as nice as we were last year. I'm not going to take the time to go in and type this in every single box. I'm going to trust that advanced students know these are the things that you need to have in your problems. So you're going to get the equation in vertex form. I may have to complete the square. We're going to practice that again today to get that. Does it open up or down? What is the vertex? What is the axis of symmetry? Y-intercept, x-intercepts. I'm going to talk about number 6 here on the next slide in just a moment. How many real solutions to whatever a related quadratic means. And then plot points. Most of the time we're going to be finding 5 of them because the vertex will be one of them. And your y-intercept will be one. And then you'll reflect that to get another one that's symmetric to that. And then maybe your x-intercepts or maybe a couple of other lattice points, just depending on the problem. There'll be a couple where it's next to impossible to get any others that you can label on your graph, but most of the time we want to have a pretty true shape for how fat or skinny it is. And when you guys just do 3 points like that real close together, it's real hard to figure out, does the graph go like that? Or is it more like that? And you get way off if you just have 3 points close together. So most of the time we're going to try for 5 of them on there. Need to label which one is which, since I'm not writing that in there, but it'll be in shorthand. It's not going to be writing out whole long sentences about that. So just waiting for you guys to get some of the rest of this copied down. And then we're going to talk about that related quadratic. Related quadratics are because we generally give you 2 kinds of questions in problem sets that talk about quadratics, right? Sometimes we say, here's a quadratic, draw the parabola. Other times, what's an example of a quadratic problem and what you have to do? Anybody remembering? Okay, well, let me go ahead and get that much up here to help out. So I'm going to get the screen shade back up there. So sometimes we have y equals ax squared plus bx plus c, and then we say get that in the vertex form and draw the graph. Other times we say ax squared plus bx plus c equals 0, and we say solve it, which means come up with the numbers that x equals. Right? Some quadratic problems you're supposed to draw a parabola. Some you're supposed to solve and say what x equals. The difference is when it has x and y in it, you're drawing all of the xy points, so you're drawing the parabola. When it is equals 0 and it only has the x in it, then you're solving it. Those are related quadratics. So the relationship between them is the x-intercepts are going to be related to the real solutions. So if I drew the parabola and these were my x-intercepts, that means I have points that are something comma 0. So that means the y was 0. So if I change the y to 0, those are the points that I'm talking about. Do you see how those are connected to each other? So when I'm asking for the x-intercepts, that's also what are the real solutions of the related quadratic, or how many real solutions are there? You're looking for how many x-intercepts. If we have a parabola that looks like what I've just drawn here with 2 x-intercepts, we have 2 real solutions. If I have one that has no x-intercepts, so maybe it's something like that, then I have no real solutions, just complex ones. If I have one x-intercept, that means I have put a P in for that. If I were to factor the quadratic, I'd have a parentheses squared. So if I solve by factoring, I'd get the same answer twice. That's called a double root. That's when the vertex, whether opening up or down, is right on the x-axis. So you get those connections between them. Okay, let's practice on a few examples of how we do the graphs, depending on what form the equations and how do we find all of these things and get them labeled. So first one, y equals -2 x minus 1 squared plus 2. Is it already in vertex form? So that means I can call on anybody's name and you can tell me right now what the vertex would be. So Casey, why don't you help me with that? What is the vertex? The opposite of what's on the inside, the same as what's on the outside. Okay, everybody point. Does it open up or does it open down? It opens down. Abby, how do you know? Okay, because we have this negative out in front, it opens down. What will my axis need to be? Ryan? X equals what? I shouldn't hear. X equals 1 because it goes through here. So if the vertex is 1, 2, here's my parabola opening down. This is going to be my axis of symmetry. So far, so good. Okay, we need to get our intercepts. How do I get the y-intercept? How do I get a y-intercept for anything ever? Chloe? Plug in 0 for x. So if x is 0, let's say I need to do a little bit of work. Y is -2. 0 minus 1 is -1, and I need to square that. And then add 2. What am I going to get? Oh, nice. So 0, 0 for my y-intercept. Okay, tell me an x-intercept. I'll do another bit of work for this particular one. That's also an x-intercept, isn't it? So we could label that one as both the y-intercept and an x-intercept. Okay, so I've got my parabola doing like this. Use symmetry, Aiden, and tell me another point on that parabola. So 1 over this way from the axis of symmetry, 1 this way, 2, 0 will be my other x-intercept. Okay, then I ought to get one other one. So I've got all my x-intercepts and my y-intercepts, so let's get another lattice point. And so, I don't know, what do you want to plug in? Gina, what do you want to plug in for x to get another point? Do you want to plug in a half? That's not going to give a lattice point, is it? So we've got 0, 1, 2, do you want to use -1, -2, +3, +4, what do you want to use? Okay, so we're going to pick -1. We're going to plug that in. So y is -2 times -1 squared plus 2. And let's see, that'll be a -2 squared. What am I going to get here? -6. So -1, -6. And what's going to be symmetric to that? Maya, what's another point that's going to be symmetric to this -1, -6? I don't think you meant -3, -6. I think you meant +3, -6. And there's our parabola. Easy enough? Kind of starting to come back? Okay, let's make it harder then. That's the way I always work, right? Is this in vertex form? So we have to change it around so it's in vertex form. And I just gave you on the list of steps, what's the method you have to do to get there? Completing the square. So when we learned to complete the square last year, we got the x squared and x terms on one side and everything else on the other side, right? So we are going to take x squared minus 2x equals y minus 2. Then we are going to look at this x squared minus 2x and figure out how do we complete the square on that so we have x plus or minus something squared. Who can tell me how I figure out what goes in this parentheses with the x? How do I go from x squared minus 2x, completing the square to get what goes in here? Grace?
Use 2 to multiply by 1.
Say what now?
Use 2 to multiply by 1, which is 1x, and then
Use 2 to multiply by 1. You've kind of confused me with what that means.
so 2 times 1, and then
Why am I doing 2 times 1? How did?
if we classify that as A, B, C, A multiplied by C.
With the factoring and everything in there, okay? We generally talked through a little bit different vocabulary on how we complete the square. We take half of whatever that x coefficient is. So we're going to take half of the -2, and that's what needs to go in here as a -1. Seeing at least one person, thank you, Avery, nodding your head. Yes, I remember doing that. Take half of that. Okay, now we want to FOIL out what is x minus 1 times x minus 1. It is x squared minus 2x plus 1. Did I get that right? But when I'm doing anything with an equation, is it okay to just add 1 on the right? If I add 1 on the right, I have to add 1 on the left. which means that over here I really had y minus 1. I'm almost to vertex form now. I need y equals, not y minus 1 equals. So I'm going to keep my parentheses squared, x minus 1 squared, plus 1. Now is it vertex form? So, Avery, what will my vertex be? Opposite of what's inside the parentheses, same as what's on the outside. So 1, 1 is the vertex. Everybody, does it open up or down? It's going to open up. Axis is going to be x equals 1. So I'm going to have one that's going like this. That is opening up. Let's get the y-intercept. Now, if they make you do the work of completing the square, that means it's going to be easier to get the y-intercept, if you're smart about it. If you have to do the work of completing the square, look back at the original equation, whether you copied that onto your paper or you're looking back in the book. Because if x is 0, and you just put zeros in for the x's here, see how easy it is to get y? So y is, so the y-intercept is 0, 2. What's another point? Another point will be 2, 2. It is opening up, so tell me about y-intercepts. Catalina, tell me about x-intercepts. So there are no x-intercepts. And so we probably ought to get another couple of points on there just so we know how fat or skinny to draw this thing so our graph looks decent. So we can pick something else. We've already used 0, 1, and 2. Let's see, 1, 1 was the vertex. So we could use -1, -2, -3, any of those integers, 3, 4, 5. We could use any of those integers. So what do we want to use? Abby H., what do you want to use for x to get another point? Okay, so Abby wants to use 3 to get another point, and then pick whatever equation you think it's easier to plug into. You can do it up here, you can do it here. I'm going to say, let's go to this one right here. So if x is 3, what's 3 minus 1? Squared plus 1. So we know we have the point 3, 5. Symmetric point, 1, 2, 1, 2, -1, 5. And there's our parabola. Okay, I want to do one last completing the square because there's another trick that you have to worry about sometimes. If it does not start with 1x squared, if it starts with -1x squared, or if it starts with 2x squared, or -5x squared, or a half x squared, there's an extra step that you're going to have to do as you complete the square. And some things you're going to have to really be careful about and think about. First thing, we will still move the 3 over to the other side, so we now have a y plus 3. And then we're going, that means we have the -x squared minus 4x still on the right-hand side. We only know how to complete the square if it starts with 1x squared. So we need to factor out that -1. So we are going to have x squared plus 4x. Does that much make sense to everybody? Now, I'm going to just keep the plus 3 like it is. I am going to keep the -1 out in front. And I'm going to figure out how do I complete the square on x squared plus 4x. So what did we say we needed to do to the 4 to get the number that goes in here? We need to take half of it. And it's easier to say take half in case it's a fraction. Half of plus 4 is plus 2. FOIL out x plus 2 times x plus 2, and you have x squared plus 4x plus 4. So far, so good. However, is that really a plus 4? What is it really? It is really a plus 4 that's multiplied by minus 1, so it's really a minus 4 is what I really changed on the right. So if I really have just subtracted 4 on the right, what do I have to do on the left? Subtract 4. So this becomes y minus 1. So completing the square, I have y equals minus 1 times x plus 2 squared plus 1. Is that in vertex form? Ariel, what's the vertex? Negative 2 comma 1. Open up or down, everybody? Axis, everybody. X equals negative 2. So here's my axis. It's going to open down. Let's get our x-intercept. So if x is 0, look back through all of the equations. Which one's going to be the easiest to figure out y? The original one, way up here. 0, 0. What's the y-intercept going to be? So that's the y-intercept. 0, negative 3. Do we have a symmetric point? Ava? I see you pointing up there trying to count your boxes. So 1, 2 this way, 1, 2 this way. So negative 4, negative 3 is symmetric. Got my vertex here. Then we probably ought to get, let's see, we want to get our x-intercept as well, right? So for our x-intercept, the easiest place to go for an x-intercept is where you still have y plus or minus something. So for the x-intercept, y is 0. So that means I have minus 1 is minus x plus 2 squared. All I've done is put a 0 in for the y. And I'm going to solve that. If I multiply both sides by negative 1, 1 is x plus 2 squared. When you have parentheses squared equals, how do you solve an equation? Plus or minus square root. It's just square root on that side. So that gives us x plus 2 is plus or minus 1. This one's going to be nice since it's an integer. Some of them you'll still have a square root in there, and you just do the same process. That means subtract 2 from both sides. X is negative 1 minus 2, which is negative 3. Positive 1 minus 2, which is negative 1. So if I have negative 3, 0, negative 1, 0, I can plot those. And then I can fill in my parabola and try your best to get them to where they're curved at the vertex, not pointy. So any questions with that? They get a little bit messy, but it's kind of coming back what we did last year. All right, then we will call that a day for taking notes.